Today's lesson is over Unit 1, Acquisition 3 on Mass Spectrometry. So this is a technique, an analytical technique, where we can enter a sample into our mass spectrometer, and it is going to separate atoms or molecules based on what's called the mass to charge ratio. And so when it does this, it's going to separate our sample or atom or molecules based on their masses. And so we can use it to calculate our average atomic mass and therefore identify either the atoms or molecules in our sample. I'm going to post a video for you guys that explains mass spectrometry a little more, goes over more of that analytical technique of how it works. So feel free to check that out. What I want to focus on today are the calculations. So the first one we're going to look at is for chromium. So chromium has 4 stable isotopes, a sample of chromium was inserted into a mass spectrometer. And the following results were obtained. So usually for these types of problems, you're going to be given a data table. So we have our M to Z ratio, and then we have our relative intensity. Alright, so let's talk about what this data gives us. So the M to Z ratio. This is what we call the mass to charge ratio. Usually, Z is for our formal charge. It's usually going to be +1. So anything over +1 is just going to be itself. So M is for mass. In our case, we are going to assume that the M to Z ratio is equal to the mass of the isotope. So this would be an isotope with a mass of 50 AMU, 52, 53, 54. Next, relative intensity is the proportion of each isotope. So that is what we have in our table. That's what the M to Z ratio is, and that's what the relative intensity is. Sometimes you'll also be given a graph. Sometimes you will be asked to graph. When we are graphing, M to Z is always on the X, and relative intensity is going to be on the Y. Alright, so we can just go ahead and graph this. So my isotope with a mass of 50 is about 1.43. Mass of 52, about 27. And again, this is just a rough sketch, so we can draw our peak in 53. About 3.17, and then this one less than 1, very small. One thing that you might be asked to do is to label each peak with the isotopic symbol. So I know this is chromium 50. And if you wanted to, you could also add in your atomic number. So we can head to our periodic table. Chromium has an atomic number of 24. This next peak has a mass of 52. 53. And 54. You will also be asked to calculate the average atomic mass. So we know our equation from the last lecture. Average atomic mass is going to be equal to the mass times the abundance. But we don't have our abundance. So step one, the first thing we have to do is calculate the total intensity. And we're going to do that by adding up all of the relative intensities. Step two. Once we have the total intensity, we can calculate the relative abundance. So relative intensity is the proportion of each isotope. So the first isotope, its relative intensity was 1.43. Out of a total intensity of 33.33. So pretty much all we're doing here is figuring out what percent of our sample had a mass of 50. 1.43 out of a total of 33.33. So about 4% of the sample had a mass of 50. All we're doing is part divided by the whole. Chromium 52 had an intensity of 27.93 out of our total intensity. Almost 84% of the sample has a mass of 52. Again, all I'm doing is a normal percent calculation. Part 3.17 divided by the whole. And then last one, chromium 54. Once we have our abundances, these are now the abundance. Well, now we can calculate average atomic mass by doing the abundance times the mass. And then last step is we want to add up all 4 of our isotopes. And I would get about 52.07 AMU. Let's think about our 3 checks. First, this is an average. It needs to fall somewhere between 50 and 54. If your answer does not fall between the lowest mass and the highest mass, you did something wrong. Next, look at which isotope is most abundant. Well, that would be chromium-52, about 84% abundant. Since chromium-52 is the most abundant, it makes sense that our average is closest to 52. Lastly, I told you it's chromium. If you know the identity of the atom, you can always look on your periodic table. Chromium has an average atomic mass of 52. So again, if you don't get an answer similar to what you see on the periodic table, you might have done something wrong. Maybe you had a math mistake. Go back and check your work. Okay, example number 2. Given the unknown below. So we have a data table. We have the M to Z ratio. And we have the relative intensity. And just 3 isotopes. So just looking at this data, we could make a prediction that our average atomic mass is probably going to be pretty close to 20 because the isotope with the mass of 20 is the most abundant. But just to be sure, we are going to calculate the average atomic mass. So again, step 1 is we need to calculate the total intensity. And we do that by adding up all of our relative intensities. Once we know the total intensities, we can calculate the abundance by doing part over whole. The first isotope has a relative intensity of 114 divided by a total intensity of 125.4. About 91% of the sample has a mass of 20. We can do the same thing with the next isotope. And the third isotope. once you calculate your abundances, it is exactly like a normal average atomic mass problem. We are going to do mass times abundance. So we could take our abundance and multiply it by the mass. The isotope with a relative intensity of 114 has a mass of 20. And so on and so forth. So now we do average atomic mass, mass times abundance of isotope 1, plus mass times abundance of isotope 2, plus mass times abundance of isotope 3. And I got 20.17 AMU as my answer. First two checks. First, does your answer make sense? It is an average. Averages have to fall somewhere between the lowest mass and the highest mass. So first, make sure that your answer falls between 20 and 22. It does. Next, we already talked about this. The isotope with a mass of 20 is the most abundant. If we were to change our abundances to percent form, about 91% abundant. So your average should be closer to 20 than 21 and 22. So just two kind of checks to make sure. Self-check your answer. How did you do? So I did not tell you the identity of this unknown. So you might also have to identify it, and we can identify it by using its average atomic mass. So remember, average atomic mass is the number on the bottom of your periodic table. We got 20.17, which is really, really close to neon. Neon has an average atomic mass of 20.18. So this is most likely neon.